Hello everyone! Welcome back to the CATIA Learning Path series. Until now, we have learned the major commands and toolbars available in the Sketcher workbench. From this episode onwards, we will start applying those commands through practical exercises. In today's exercise, we will create this fully constrained mechanical profile using lines, arcs, circles, slots, fillets, construction geometry, symmetry, and dimensional constraints. Our aim is to have this geometry fully constrained, and all dimensions should be in millimeters. So, let us start. So, we need a new cat part to start with. Go to File and create a new part as I'm showing here. Create a positional sketch. It will be better than sliding sketch because it gives a good control. I will keep the origin at the center of our geometry so that we can take advantage of symmetry. Before creating the actual profile, I will establish the main horizontal and vertical references. These references will help us position the geometry accurately and maintain symmetry. Make sure you are giving constraints on the go always. Now I will start creating the outer profile. Instead of creating both sides independently, I will first concentrate on one side of the profile. Next, I will create the stepped side profile. I will apply the vertical and horizontal constraints according to the drawing. The height difference between these two levels is 20 millimeters. Please, in between, always check the requirements, because with the flow of work, we also need to make sure that the parameters are taken as per input image. It is always advised to not start with filleting directly, but to draw lines or the profile first, and then draw fillets so your sketch can be controlled parametrically well. To draw a good fillet here, we need a center reference point, as there is not much information available, so we'll take R25 as an input only here. Please make sure the reference geometries should be construction elements only. If not, then use Construction tool to do so. As you can see, by mistake, we've made this sketch over-constrained. Green color is for iso-constraining, and pink is on for over-constraining. So whenever you see this happen, check for the exact cause of over-constraining sketch and then correct it. Now comes the trimming part. We'll use trim function to do so and get rid of extra lines. Here we go now with filleting. For doing so, we'll use corner function and give required fillets as per input drawing. If we don't see any proper inputs, then we'll guess as per image and do so. Always remember, fillets will be given at last, unless it is special case. It will help you draw your sketch faster and also with good control. The required radius is 15 millimeters. I will also make sure that the connecting elements remain tangent. Now let us create the slot at the bottom. I will first position it symmetrically about the vertical center line. The required length is 50 millimeters, and the end radius is 8 millimeters. I will then position the slot vertically using the 18 millimeter dimension shown in the drawing. Here we are, doing nothing but creating reference to place our slot as per dimension. For any sketcher, it is one of the key requirements to have reference given correctly. Now we will place the circle with the given diameter as per the input. Then we will add lines on top to complete the slot, making sure the lines are tangent to the circle. This will create our slot. However, we will keep one side of the sketch open as we need to perform a mirror operation after completing the first side. As we now have the reference geometries, the only thing remaining is to trim the unnecessary portions. Always make sure to remove the extra geometry so that you can complete your sketch faster and keep it clean. As mentioned earlier, the reference geometries should be in construction mode. This ensures that they do not become part of the actual sketch profile. Construction geometries are shown as dotted lines, as you can see here. Now I will create the main center hole. Its center will be positioned on our vertical reference axis. The diameter of this circle is 30 millimeters. As you can see, the reference geometry is also used here to define the center point of the circle. Alternatively, we can position the center point with respect to the H and V axes and the sketch origin to make the sketch more parametric. For now, I have used the existing reference geometry available here. Next, I will create the two mounting holes. The diameter of each hole is 12 millimeters. The center of the first hole is positioned 45 millimeters from the vertical center line. Its vertical position is 30 millimeters from the bottom reference. Instead of dimensioning the second hole independently, I will use symmetry about the vertical axis. It is always recommended to define dimensions from the sketch origin and H and V axes rather than from existing geometry, unless there is a specific design intent. For now, I have used the existing geometry as a reference. Since the component is symmetric about the vertical center axis, there's no need to recreate the opposite side manually. I will use symmetry to generate and control the opposite side manually. Using symmetry reduces the number of independent dimensions and keeps the design intent much cleaner. Use the auto propagation feature for quick selection of the required geometry. Once selected, apply the mirror function, as you can see here. Before completing the exercise, let us check the solving status of the sketch. As you can see, the sketch is still under constraint. However, this will not affect our final result because the remaining unconstrained elements belong only to the reference or construction geometry and do not control the main sketch profile. As a designer, it is important to understand that achieving an ISO-constrained sketch is good practice, but the main priority is to fully constrain the functional geometry that controls the shape, position, and parameters of the part. Now, let's exit the sketch and check whether the pad operation works correctly. If the pad operation works, it generally means the sketch profile is valid. If it fails, we may need to check for issues such as bad topology, open or overlapping geometry, or reference elements like points and lines that were not placed in construction mode. Thank you for watching. See you in my next video.